All right, welcome to our 4.6 lessons. We're going to talk a little more about isosceles and equilateral triangles. The basic definition you should already know, but now we're going to learn a couple new things and apply some concepts. We'll come back up to these, the vertex angle and base angle in just a little bit. Just remember that an isosceles triangle has two congruent sides, the big thing right there. Okay, we have a couple diagrams and examples over here for you to read. We're going to use this diagram right here, triangle ABC, and we're going to classify our sides and angles and base angles, the base, the vertex angle, and everything. First, we want to classify this by its sides. So by its sides, we see right here that we have two congruent sides, and that is that's the definition of our isosceles triangle. So, classified by sides, we would have isosceles. Okay. Isosceles triangles are going to not all the time, but in this case, we don't really have the measurements, but we're going to go ahead and say this is going to be an acute triangle based on the angles. Now we're going to talk about the legs. Well, it doesn't mention up at the top, but your legs are going to be the congruent sides. So we would have segment AB and segment AC will be our legs. Okay, it's going to be this guy right here and this guy over here. All right. Next, we're going to look down here at our base, talking about our different lines, our different sides. Your base is going to be at the bottom. Well, we don't want to classify it as the bottom necessarily because it's not always going to be at the bottom. Your base is going to be the third side. That's not a leg. So this would be segment BC. We talk about the angles. We go up here to base angles. These are the two angles formed by the base to the congruent sides. So these are going to be actually what I like to call across from the congruent sides. So with isosceles triangle, a good thing to remember is your base angles are going to be congruent, and the congruent angles are across the triangle from the congruent sides. So your base angles will be angle B and angle C in this case. Your vertex angle, as it says up here, is the angle with sides that are the legs. So this is going to be the angle that's formed by your two congruent sides of an isosceles triangle. And so this will be angle A in this picture. All right? Now, keeping in mind that it talked about that your congruent angles are across the triangle from your congruent sides, over here on this example, we are going to find the measurement of MP. I'm sorry, the measurement of angle P. And I'm highlighting that so that I can also come over here and say, this is what I want the measurement of. Solving for X is not going to be good enough. I've got to take it a step further. So I'm given that angle M is 6y and angle P is 8y minus 16. The measurement of angle P is not 8y minus 16. Okay, we've got to solve for y and then use our substitution property and plug back in. So if we see here, we have our congruent sides, segment MN and segment NP. And like we discussed, across from your congruent sides are going to be your congruent angles. So we've learned that when two angles are congruent, their measurements are equal. So we can just set this up equal to each other. 6y equals 8y minus 16. And then we'll go through a process of solving for y. I like to move my smallest variable. So I'm going to move the variable with the smallest coefficient. So I'm going to move this guy over. What ends up happening is I temporarily have a 0. It's okay. And then I'll have a 2y minus 16. Some students get a little freaked out with this. That's all right, because look what happens next. We have to add that 16 both sides so that we can get rid of it next to the y. So then we'll have 16 equals 2y. Last step of solving for y in this problem, divide both sides by what's attached to that variable, and we'll come out with that y equals 8. Now again, we wanted the measurement of angle P. So what we now need to do is take that the measurement of angle P is equal to 8y minus 16. We're going to use our substitution property, and we're going to take this y, substitute it in. So we get 8 times 8 minus 16. This will wind up being 64 minus 16, giving you the measurement of angle P, When you do that math, do that subtraction, we're going to get 48 degrees. So you can also conclude that the measurement of angle M is 48 degrees because they are congruent. How do we know? They're across the triangle from the congruent sides. Next, let's talk about the sides. Again, this problem, solving for the variable is not going to be good enough. We want to find we want to find the length of FH. So that's going to be this side right here. So we'll have to substitute in afterwards. Now, I see here that I've got 62 degrees and 56 degrees, but I'm missing an angle measurement. So I'm going to use my triangle sum theorem to solve for that. So I'm going to add the 62 plus 56. Okay, I'm going to wind up with 118. Then I'm going to subtract that from 180 to find out it's going to be another 62 degrees. Okay, so angle H and angle G are my congruent angles. Just like the congruent angles are across the triangle from the congruent sides, it works the same way if I have two congruent angles, the congruent sides are across. So that's going to tell me side FH and side FG will be congruent. So then, again, if two sides are congruent, two segments are congruent, their measurements are equal. So we will set this up equal to each other. So 4y minus 2 is equal to 2y plus 2. We'll go through and solve. Add to both sides, get rid of that 2, negative 2 next to the y. 2y is going to equal 4. After we divide, we find out the y is going to equal 2. Again, we need to use our substitution property, and we need to plug in for the length of FH. The length of FH right here is 4y minus 2. So what I want you to do on your own is you're going to go ahead and you're going to do the substitution on your own. Okay? And then we can check that in class. Make sure that we're substituting correctly. And this should be an equal sign. Make it look more like an equal sign for you. And then I want you to do number 3 and number 4 on your own as well. You're going to use the same concepts that we just looked at on the ones above. Okay? So these you will do on your own. All right? And then we'll take a look at the next page. This is our isosceles triangles. Let's take a look at our equilateral triangles now. Okay? With your equilateral triangles, we will need to remember that all sides are congruent. So we'll go through the problems, but if I give you two sides, you can figure out the third side. If I give you one side and I tell you it's equilateral, you know all three sides. The other thing is that all angles are congruent. Okay? And that's what this is talking about right here. The equilateral triangle corollary for 4.4 is telling you that not only are all angles congruent, but all three of your angles are going to be 60 degrees always. Every single equilateral triangle, all three angles are 60 degrees, no matter how big or small it gets. So that's going to be a new magic number that you want to remember. Anytime that we have to solve for something, we can just set it equal to that 60 degrees. Okay? So the first problem here, we're going to be finding the length of JL. JL is right here. Okay? First, we have to set up to solve. And we see that all three angles are congruent, which is kind of like the isosceles triangle. The sides across from the angles are going to be congruent. In this case, it's all three. So equilateral triangles are also what we call equiangular, meaning they all have the same measurement. All the angles are the same. Okay, equilateral, lateral meaning side, equiangular, angular meaning angles. So we can take these two statements, these two algebraic expressions. We can set them equal to each other. Let me do my 4t first. So we have 4t minus 8 is equal to the 2t plus 1. We'll go through our process of solving for x. Remember, we got variables on both sides, so we want to get rid of that guy first. I'm going to move the variable with the smaller coefficient. So I wind up with 2t minus 8 is equal to 1. Now I need to get rid of that 8, that minus 8 next to the 2t. So I get rid of that by doing the opposite. I'm going to add 8. 2t will equal 9. When I divide by 2, t is going to come out to 4.5. So we've got a decimal. Again, we need to substitute in. So here we want JL. So JL is equal to 2t plus 1. So I want you to go through and I want you to do the substitution. Okay. All right. The next problem is going to be pretty quick, straightforward for x. And this is where I was telling you with x, since we have here that we've got an equilateral triangle, okay, all three of our sides are going to be the same, and all three angles will be the same. Now, when solving for x, since it's in an angle, we can go and do 2x plus 2x plus 2x, set that equal to 180 for our triangle sum theorem. But what's even better here, now that we have an equilateral triangle, when we're solving for x, we can take a look right here. All we have to do is take one of those two x's and set it straight equal to 60. Why can I set that equal to 60? Because it's an equilateral triangle. That is the only reason. Okay? So then, very short and easy, divide by 2 on both sides. We find out that x is going to equal 30. That is one of the things we wanted to find. The next we want to find is y. You're going to solve for y on your own. All right? And just to kind of give you a hint, remember that if we have an equilateral triangle, all sides are equal. Okay? Just kind of draw it like that. So you're going to go ahead and solve for y on your own, and we'll check in class. Of course we've got proofs, guys. Come on. You know that. You know we're going to have proofs. So let's go ahead and check out this proof and get through it. Nice and easy. The first thing we are told is our given is that S is the midpoint of segment RT. So S right here, even though it does not look like the midpoint, never trust your eyes. Go with what they tell you, okay? So since this is the midpoint, we know that we're going to be cutting this segment RT into two congruent segments, so we want to mark that. So because this is the midpoint, I can now, well, let's go ahead and put in our other given as well. Our other given is that angle 1 is congruent to angle 2 as a given. Actually, erase that, scratch that. I'm going to say that because I need you guys to start seeing that givens are not always one after another. So I'm going to go ahead and we're going to split it up so you guys get used to seeing that. We'll go ahead and we'll make a statement of what happened with that midpoint. When we got that midpoint, we cut it in half, so we ended up with segment RS. Segment RS is going to be congruent to segment ST. Now, why are we allowed to say that? This is where you're going to see this a lot, and you guys need to start getting used to it. These two segments are congruent because the statement above had that word midpoint. So this is your definition of midpoint. All right. Now we'll go to our next given, and we'll say that angle 2 is congruent to angle 1 is congruent to angle 2. Trying to make the video as short as possible, and I'm rushing. This is why you don't rush in math. And over here, we're going to say it's our given. Go to your picture and mark it. Okay, it's very, very important that you start marking this. I know some students don't mark these in their pictures. You need to. Angle 1 is congruent to angle 2. And based on what we learned, and we're going back to an isosceles triangle here. Okay, we cannot conclude it's equilateral because we're not saying that angle R is congruent also. So all we can detect is that angle Q and angle R, or angle 1 and 2, are going to be congruent So we are now, based on what we talked about the isosceles triangles, we can also determine that the sides across the triangle from congruent angles, those sides are also congruent. So now we can come down here and we can say that segment QR is congruent to segment RS. And why are we allowed to do this? Well, this is going to introduce a new theorem to you. The theorem that the two angles across from congruent sides are congruent, as well as the two sides across from two congruent angles are congruent. This is your isosceles triangle theorem. So isosceles triangle theorem. And I will repeat that, remembering that if you have an isosceles triangle, you find the two congruent sides, go across the two congruent sides, and those two angles are congruent. If you have two angles that are congruent in an isosceles triangle, you go across the triangle to the opposite sides, and they are also congruent. That is going to be your isosceles triangle theorem. Either direction that you go, from angles to sides or sides to angle, it's going to be your isosceles triangle theorem. Now we're to prove that segment QR is congruent to segment ST. Well, here we're going to go ahead and write down segment QR is congruent to segment ST. So we need to go up and we need to use statement 2, 4, and 5 and try to decide, okay, do we have transitive or do we have substitution? Remember, with transitive, you have to cross out the middle man. So you'd have to go diagonally, okay, between statement 2 and 4, and it'd have to be the exact same thing, and it's not. Now, if we go diagonally from the top left to the bottom right, they're the same, but that's not transitive. The only way for it to be transitive is you go from the top right and the bottom left. Those two cross off, okay? But that's not what's going on here, so we don't have transitive. Instead, we have substitution. Okay, so you only have a few things that you need to do on your own, and it's just setting things up, solving for x, substituting in. Have that done, ready to look over in class. Good luck.